Well, I told you the last time that we would talk exactly more this time about what that equilibrium constant actually means. And it's the size of the value that is going to tell you a lot about the reaction. You want to keep in mind that the equilibrium constant is a ratio between the concentration of the products and the concentration of the reactants. And so therefore, what that means is that if your equilibrium constant would be exactly equal to 1, that means that your products and your reactants are going to be balanced between each other. If the concentration of the products is much greater than the concentration of the reactants, then that means that your K is going to be greater than 1. And so that means the reaction is going to be weighted towards the product. So what that means is that the reaction is going to proceed much more towards the products before it reaches equilibrium. In fact, if your K value is greater than 1 times 10 to the 6th, you can assume that the reaction is only going to go one way, completely towards the products, just like the reactions that we've been studying really all year long. We've been making the assumption that they go all the way to products, and if this constant is that big, then that's what we can assume for the reaction. Now, I do want to tell you that different textbooks and different authors will set this dividing line in other places. I have seen other textbooks where they say if K is greater than 10 to the 4th. Regardless, I want you to be aware that dividing line can change a little bit, but the author of your textbook says 10 to the 6th, so that's the dividing line that we'll use for this particular class as well. On the other hand, if you end up having a whole lot more reactants than you do products, that means your bottom number is going to be much bigger than your top number, which means that K is much less than 1, and so the reaction is weighted towards the reactants. So in other words, the reaction doesn't proceed very well at all. You still have a whole lot of reactants sitting in your reaction container and not very many products. And if K comes out to be less than 10 to the negative 6th, again, we're going to assume that the reaction only goes one way, and that's going to be proceeding from products to reactants. So it's actually like it's going to be going backwards. So if I look at the problems that we did in video number 1, the equilibrium constant that we got for the first problem was 463. So since that equilibrium constant is greater than 1, I know that that particular reaction was weighted towards the products. The second equilibrium constant that we calculated was 2.8 times 10 to the minus 6th, and that is where K is much less than 1. Remember that if you have a negative exponent up here, that means that it's a very, very small fraction. And so therefore, this reaction was weighted towards the reactants. In fact, this one is really, really close to the dividing line. It's not quite there, but the reaction for all practical purposes is only going to be going one direction. So let's look at a couple of other examples here and figure out what's going to happen with these. So if I look at this particular reaction up here, nitrogen dioxide plus chlorine yields 2NOCl plus O2. I've been given that the equilibrium constant, which remember is dependent on temperature, the equilibrium constant for this is 4.6 times 10 to the 6th. So what do I know about this particular reaction? Well, because this equilibrium constant is so large, I know that the reaction is only going to go one direction. So I can actually rewrite this particular reaction with just a single directional arrow going towards the products. 2NOCl plus O2. Because this is so large, this arrow is only going to go one direction. Okay? So look at the second example. 2 chlorines plus 2 waters yields 4 hydrochloric acids plus oxygen. Here, the equilibrium constant for this reaction is 3.2 times 10 to the minus 14th. Well, that's a tiny number. And it certainly is much smaller than 10 to the minus 6th. So again, the reaction is going to go one direction, and it's going to be very much weighted towards the reactants. Now, we normally don't write reactions with arrows going from right to left. So if I'm going to write it with just one arrow, I tend to go ahead and turn this around. So to write this with a one directional arrow, I'm going to flip this and put it over here. 4HCl plus O2 yields 2Cl2 plus 2H2O. Okay? So here, very, very large equilibrium constant. We'll have a one directional arrow going towards the products. A very small equilibrium constant will give me a one directional arrow going towards the reactants, but I do tend to flip it around and write it the other direction. If I look at this particular reaction, I've got methane plus chlorine is going to yield CH3Cl plus hydrochloric acid. This has an equilibrium constant of 1.2. It's not exactly equal to 1, but again, just because it is close to 1, you can tell that here my reactants and my products are going to be relatively equal to each other. It's slightly weighted towards the product side just because it is greater than 1, but it's not much greater than 1. So this reaction I cannot write with a single directional arrow, and the double-edged arrow will have to remain. Okay, so you are going to be doing some evaluation of reactions and the reaction equilibrium constants that go with those particular reactions today.